Hello everyone, welcome to this week's building public stream. This week we're going to be looking at how to extend the JSON RPC server to include a custom method. This will be a good opportunity for you all to learn how to contribute to JSON RPC servers, and for more specifically for how you can add a new EVM method or add a new custom method, as we're going to do today, to any JSON RPC server from any network. So first things first, you need to have a local network running on your local machine. I already do have that. Let me quickly show you. So I have a network of 10 nodes here. I just started it right before the stream, so you see that only one of the nodes is active and 9 more are still joining. And then you also need to have your, let me show you. You need to have the LDRPC system set up, which is the distributor, the collector, and the service validator. Those are some of the prerequisites that you need to have up and running before you'll be able to do this. So we've already set all of these things up in a previous stream. I think Sonia has also shown how to set it up in one of her streams. So I didn't want to go over how to do all of that again because it takes some time. But yeah, you can easily see all the services that we have running if you do a PM2 list. Then you see we have the collector, API server, the data server, the log server. We have the distributor and the service validator. So these are the services that you need to be running alongside your local network. While you have that all set up, we can go ahead and clone like a new version of the JSON RPC server, which is what we want to do today, right? So let's do that. Actually, I'm going to minimize this so that it's right there. Okay. All right, so I'm gonna do a quick clone of this. Let me zoom in a bit more so that it's easier to see the screen. All right, I'm gonna do a git clone. And let's npm install. You should also see that I'm using Node version 18.16.1, which is the version that Shardeum requires. So if you're on a lower version or a higher version, it's recommended to be on this particular version, for now at least. So it looks like that's done. Let's go ahead and open it up in code first. Right, so what I will do now is, before we actually run it, there's a couple of configurations that is required. Again, this config that I'm going to do now, we already did it in the previous videos where we set up the local network RPC system. If you look at our previous streams, it's on YouTube. You should be able to find out how we set all of these systems up. But I'm going to go ahead and do it quickly. So you go into the src directory, you find the config.ts file. There's a couple of things we need to set here. One of them is the collector sourcing. We need to enable it. So let me just do it. It's a big code base, so things are not that easy to find. I just have to click around collector sourcing, set this to true. It's one of the first configs we want to do. And then for the service validator sourcing, we want to enable it and also change the URL. So let's set this to true. And then for the URL, we want to use 7001 and save that. I think the other thing is the WebSocket. We have to enable that, but I think it's enabled by default, so we might not need to do that. Yeah, so it's true by default. So this should be all the config changes we need to do to be able to get this working. All right, I'm going to recompile, run compile, so that these configuration changes that we made will take effect. And then I'm going to do node pm2 js1. Sorry. So this will run one RPC server for us alongside our other running services. So now, if I do pm2 list again, I should see that I now have the RPC 8080 running on localhost. All right, the setup is done. I think the next thing I want to do is let's try it out. Let's try it out and see if it is indeed working. Storage. Okay, so this should work. So now you see that we are getting responses from our JSON RPC server running on localhost 8080. Of course, there's no invalid address. Don't mind the message because we've not passed any address to the params. But I just wanted to confirm that we can send requests and get responses from the RPC server. So now, what we want to do today is, if you look at the API file, this is where we have, I'm going to collapse this. This is where we have most of the EVM methods that we use. So let me scroll down a little bit. So yeah, so you can see we have transaction count, we have get blocked by transaction count, we have what else? But actually all of that, all of those EVM methods are defined in this file. See get code, sign transaction, send transaction for when we want to send a transaction. All of that is happening in this file. And what we really want to do today is add a new method kind of to this file that will give us the ability to perform like our own custom kind of interaction. In this case, we want to return the list of active nodes in the network, right? So at the moment, I think you'll be able to see that we have, where is my other browser? Here. We have 10 active nodes in the network right now. We can also confirm that just by looking at the archiver. So let's do localhost 4000. Perfect. So this would return all the active nodes in the network for us, and we can see that here. What we want to do though is to expose this data through our JSON RPC interface. So instead of coming to the archiver directly, we can we have storage at here. If we can do something like get node list and make a request, and then that would send us the response that includes all of the nodes in the network. So that's what we want to do. All right, let's go ahead and do it. The first thing that, because I've spent some time going through this code base, the first thing that I noticed when I was trying to look at it is that we already have this function inside of the utility file. Actually, there's a couple of ways that the JSON RPC server, this particular one, gets data from the network. If you look at the external directory, you see that we have a collector class here that it uses to grab data from the collector if it needs data. So the JSON RPC server is just like an interface between external parties and Shardeum services. So depending on what the request is, the JSON RPC server will route it to the correct service and get the right data for you. So in this case, we want to get the list of active nodes in the network, and we will get that from the archiver. So if you look at that utils file I show you, look at the node list, you see what's going on is we are getting the archiver URL and just making a request over the network to this URL, and this is how we are serving that request. So if you look at the function definition, you see that we pretty much have all we need here. This request gets a response back, and what we just need to do is expose this request back to our client. But first, let me define that function that we're talking about. Okay, so I want to add a custom method here. Let's call it Shardeum. I wonder if this would be, should I use the it convention, or okay, since this is not like a standard Ethereum method, I'm just going to use Shardeum because it's Shardeum specific. So let's do get node list. This is going to, one second. I think this is going to follow the same convention as the existing ones. So I'm just going to type that out. It's going to be an async function. And let's it's going to take the same arguments as the ones we had before. Actually, I'm just going to grab that so I don't have to retype all of that again. All right. And then I think most of this, just to keep the convention of what we currently have, I'm going to grab all of this and just do a little bit of changes. This will then be Shardeum underscore get node list. Okay, and then for the callback, we don't need this part, so we do the create that and that and that. Okay, I think that is standard just for login and for performance tracking. For now, we want to send back a response, and we do that using the callback. Excuse me. I'm going to do null, and for now, I'll just send back an empty array. Or actually, let's do a send back some default nodes just to test out that this endpoint is doing what we expect it to. So we can have an array, an object of IP, let's say maybe 9001, something like that. And wonder what else we should add here. IP and ports, let's do ports, can be I'm just going to duplicate that. Okay, so this is, I just want to see if we are hitting the right endpoint first before we continue with our actual implementation. So let's do run compile. And then I'm going to do PM2 restart 5 because that's the RPC. Okay, so with any log, when we check Shardeum get node list, we should be able to get this response back. Let's try it, see what happens. This should be Shardeum get node lists. Of course, we don't have any params right now, so I'm going to get rid of this. Non-array arguments. So every time you make a change and you want to see it updated, you have to recompile and then restart the service. Okay, I'm going to try this again. And now we get the response. This is the default nodes that we just set up as a response. So it looks like so far our API endpoint is starting to do what we expect of it, except we don't just want to send back default data like this. We want to send back the actual data that we get that we have in our network. So let's come back to that utility file. So again, this function that already exists in the RPC server does majority of the work. It gets the heartbeat message from the network, it updates the node list from the archivers that we have on the network, and the node list already exists. We just have to find a way to expose it to our API.ts file. So let's do that here. I'm going to do export. This is going to be get node list. And we just want to return the node list. Because this node list already exists globally, so I'm going to show you. So we have the node list here. This is where we are setting the value. So the update node list function here is setting the value here, and the node list itself exists. The variable exists right here. So again, the hierarchy of it is we have this global node list variable. When this function executes, it sets the value of that variable to the active nodes in the network right here. And what we're doing now is we're just creating this function to export that node list so that we can access it from our API file. All right, so let's save this. And then what I want to do is come and import it here. So let me mark this line because it might be difficult to get back to it when you scroll away. All right, so let's import get node list from the utils file where we've created it. And yeah, this is one difficult part of working in a large code base. Is scrolling around gets really tough. If anyone knows there's usually like a VS Code command that you can just execute to automatically collapse all the functions in a code base. I don't remember what it is, but yeah, that would have been so helpful right now. I think I'm just going to search for it. I think we called it what? Shardeum _ get node list. There we go. Okay, so now instead of sending back this default data, how about we send back the actual node list, right? Since we've exported it, we've imported it here, and this function should be able to return it for us. So let's recompile. I'm going to clear. Oh, damn it. I'm also trying to hurry so I don't take too much time today. I see we have about 5 minutes left, so I'm going to try to be fast. So we'll recompile and we'll restart PM2. Then I'm going to try to execute again, and there we go. We get all the active nodes in the network coming from the archiver, and we're getting it through JSON RPC interface. So this is fantastic. At this point, if this were to be deployed as it is, anyone could get the active node list in the Shardeum network just by calling these endpoints through the RPC interface. But if that were to be the case, there would be like 1,000 nodes or 500 nodes or 600 nodes, depending on how many nodes are active in the network at the time. So what I think would be a good thing to have would be to say, if we had a way to set a limit or like pass a limit parameter to it, so that you can specify the amount of nodes that you can get at a time, because if we had 1,000 active nodes, you probably wouldn't be able to scroll through all of those. Let's see, we've got about 4 minutes left, so let me try to see if that is something that we can quickly do here. Okay, so let's say that this function accepts a limit parameter. Going to be of number type. Then we want to first check if there's no limit, or if the limit is longer than the amount of nodes that we have. If this is the case, then we want to return the existing node list, right? Otherwise, let's slice this and pass our limit. Okay, so now this function should be able to accept the limit and return that amount of nodes to us. The other thing we need to do is we need to make that happen for this particular API now. And how we do that is by specifying params. We do have like an argument type here, but it's a union, so we need to do, let's do we have our own parameters. It's going to be an array. Check if it's array. Args. Then we are going to check if this first one. Otherwise, we just return all the args. From these params, we should be able to get our limit. Let's do limit would be params.limit. Let's wrap it in a number because we are looking for the params.limit. Otherwise, we can do undefined, and then we can pass the limit to the callback, and this will then pass it to this function and do all of that checks for us. Okay, so let me try that. That's a little hacky right now, but let's see if it works. I have 1 minute to go. We'll restart the PM2 process, and here what would happen then is I would need to pass a params. This would be an array, and let's say that I pass a limit of do I need to two, and see, and here we go. So now we are able to limit the amount of nodes that we get. this is only, of course, it becomes only necessary on a live network where you can get thousands and thousands of nodes. Otherwise, if you're running a node of 10 networks like we are now, or 25, this wouldn't be so much of an issue for you. Again, this is just a little bit of a introduction, so to say, on how to extend JSON RPC servers. We've added a new method called Shardeum _getNodeList that returns all the active nodes in the network to us. We've added a limit functionality to be able to limit how much nodes we get. We can add a pagination functionality to decide how we want, how many pages, decide which page, things like that. So basically continuously update this to perform all the different things you want it to do. We will do, or maybe we can do that and add some other methods in another stream. But we are right up on time, and I did not want to take your time today. So thank you for joining us. I hope you've learned something. I hope this has been helpful to you. I'm going to quickly grab the POAP link for this week. So this is BIP 23. I'm going to put it in the chat. And while you fill out that form to receive your BIP, I will quickly, let me put it here. Yeah, so while you do that, I will just show you again the JSON RPC server that we have. So this is open sourced. We are currently accepting contributions. If you try to use it, if you see any issues, feel free to log it here or put it in the open source chat for us. If you want to contribute and need help with anything, that open source chat would also be a good place to ask your questions and get answers. We've shared a couple of good first issues that we've created recently for first-time contributors to contribute to any of these code bases. We are getting to mainnet gradually, and one of the ways that you can help us get there faster is by contributing to Shardeum in your own little ways. If you want to make a tutorial, that's fine. If you want to improve the documentation, that's welcome. If you want to do a bit more than that and contribute in a more significant way in any of our code bases, that is also fine. So this is what I have for you this week, and I think we will be, can you try to fill that form, submit your POAP, let me be sure that the form is working before we end the stream, and just let us know in the chat if you were able to do it. Yeah, I'm going to keep an eye on it. Yeah, Sonia, can you also check, try to click the link, see if you can submit successfully?
Let me give it a try.
Yeah. Okay, it's working for Sharon.
Yeah, it's working for me as well.
Okay, perfect. All right, that's it, everyone. That's all we have for you this week. Is there any other closing thoughts from you, Sonia?
I believe you have covered it all. But yes, feel free to check out our open source issues, and if you have any questions, we are here for you. We are here to support you. So whatever kind of question it is, feel free to just dump it in our channel.
That is all
Thank you so much.
Thank you, Sonia. Thank you, everyone. I've put a link to the open source chat in the chat. So click it, join us there, share your questions. If anything you want to discuss with us, that would be the best place. So thank you, Shoam. Thank you, everyone in the audience, for joining us this week, and we will see you again in 2 weeks. Bye, everyone.